Good morning to everyone. Today we are going to see about minimum spanning tree. Before we have to know about minimum spanning tree, we need to know about what is minimum spanning tree and how it works. First of all, spanning tree means it is a tree that connects all the vertices of a graph with the minimum possible number of edges. And then second point is a spanning tree is always connected, and third point is a spanning tree never contains a cycle. And this is the example for a graph. Based on this graph, we have to create a spanning tree. That means a possible number of spanning tree. The formula for a possible n equal to n power n minus 2. So n is nothing but a number of vertex. So in this graph I am using 4 vertices. So 4 equal to 4 power 4 minus 2. So 4 power 2 equal to 8. So we can create 8 possible spanning tree based on this graph, and also we have to calculate weight for each spanning tree. And this is a spanning tree example. And second one is the minimum spanning tree. Minimum spanning tree is a spanning tree is a subset of edges of a connected, weighted and undirected graph that connect all the vertices together with the minimum possible weight. And second point is a spanning tree with the minimum cast is called as minimum spanning tree. And next is a Prim's algorithm and Kruskal algorithm comes under minimum spanning tree. So based on minimum spanning tree, we can calculate minimum cast. Next is the Kruskal algorithm. So the main purpose of Kruskal algorithm means we can calculate minimum cast using Kruskal algorithm. This is the example for Kruskal algorithm. Using this Kruskal algorithm, we can calculate minimum cast. The first step is we have to identify minimum cast within this diagram. So minimum cast is 10, so we can create edge between 1 and 6. And next third step 3 is second minimum weight is 12, so we have to create edge between 4 and 3. So the main condition is it does not support a cyclic form. So without creating a cyclic form, we have to calculate the minimum edges. And step 4, the third weight is minimum weight is 14, so we can create edges between 7 and 2. And fifth minimum weight is 16, so we can create edge between 2 and 3. And next weight is of 22, so we can create edge between 5 and 4. So the final weight is 14, so we can create edge between 2 and so on. So the final diagram denotes a minimum cast from one source to another vertices. So the minimum cast is, the total cast is 37. So this is the Kruskal algorithm. The main purpose of Kruskal algorithm means we can calculate minimum cast using Kruskal algorithm. Next is the Prim's algorithm. Prim's algorithm also used for calculating minimum values. This is the example for Prim's algorithm. First we have to identify minimum cast. So in this graph 10 is the minimum cast, and the second step is we have to find out minimum cast with the help of first two edges, that means 1 and 6. So 6 having a 24 weight and 1 having 28 weight. So we have to identify which cast is low. So the cast is 25 is low, so we have to create edge between 6 and 5. And third step is we have to identify minimum weight from 5. So in this vertex, 5 and 7 having 24 and 5 and 4 having 22. So we have to identify minimum value. So 22 is minimum value. So we can create edge between 5 and 4. Next, fourth step is from 4 we can identify minimum weight from 4 to 7 to 18, from 4 to 13, 12. So the minimum value is 12. So we can create the edge between 4 and 3. So next step is from 3. So 3 to 2 is a minimum value 16. So we can create edge between 16. Then final value is 14. So we can create edge between 2 and 7. So the minimum